And so we begin. Optional Tuesday. We missed you, Braden and Rowan, and anybody else. Gigi enjoys the extra elbow room. Who? Jake is not in this class. He won't watch the video. They are missing the triple donuts day. We enjoyed the donuts. They're wonderful. So, we start with the derivative of inverse functions. Consider the function 3x minus 2 for the following examples. Let's talk about properties of inverse functions. Do you even remember what an inverse function is? So maybe you remember this. What we did is we took x and y and we swapped them back and forth. So if you remember, if we started with y is equal to 3x minus 2, we switched the x and y. We made x equal to 3y minus 2, and we solved for y. Do you remember doing that? Okay, so that's when we did an inverse function. You might be thinking to yourself, well, what the heck is an inverse function? Well, there's some properties in the x and y switch, which means the domain and the range. If you have f, the domain and the range, and you have f prime, domain and range, f inverse, the domain becomes the range, and the range becomes the domain. They swap domain and range values. Yep. So if we actually did solve, I know you guys know that 3x minus 2, it was a line with a slope of 3, shifted down 2 units. So it looks something like that. The truth is that in order to determine an inverse graphically, it's simply reflected over the line y equals x. So if you look at this line, y equals x, the inverse function should be flipped right over it. So if I solve here for y, I get x plus 2 is equal to 3y. I divide by 3, and I get 1/3 x plus 2/3 is equal to y. Turns out that's the inverse function. If I were to graph that, a couple things. Number one, it crosses the y-axis at 2/3. Does anybody know where it crosses the x-axis? Close. Yeah, if this function crosses the x-axis at -2, then its inverse is going to cross the, if this function crosses the y-axis at -2, its inverse is going to cross the x-axis at -2. And so when I graph this, you can see, does it look like the first line flipped over the line y equals x? It sure does. They are inverse functions. So they're reflected over the line y equals x. It's just the definition. The horizontal line test is very important. So Katie brought up, said, well, functions probably have to pass the vertical line test. Inverse functions also have to pass the horizontal line test. So, for example, if I draw this function, does it pass the vertical line test? Does it pass the horizontal line test? Yeah, it does. If you draw a horizontal line, it never crosses it more than once. But if I were to draw this function, does that pass the vertical line test? Does it pass the horizontal line test? It does not. And so what that means is if you were to reflect this over the line y equals x, you would get something that looks like that, right? The green and the blue together. That's not a function, is it? That's why we want this to pass the horizontal line test, so that when we find its inverse, the inverse is a function. The fact is it doesn't pass the horizontal line test. So instead, what we did, I don't know if you remember this last year. You don't have to remember this all now. I'm just trying to prime your memory a little bit and help you remember a little bit of the things that we covered, is we cut off part of this function. And we said, well, if when you take the inverse, you get a parabola, we're just going to restrict it so we have part of it. So now it does look like the one function reflected over line y equals x. So passing the horizontal line test is important as well. The last thing that I want to talk about regarding these functions is the composition test. If you took and composed two functions together that were inverses, they produce a very specific value. Anybody remember from last year what f of f inverse of x is? It produces x. And it works out that if you compose them the other way, f inverse of f of x, that will also produce x. So functions that are inverses of each other, when you compose them, they will produce x. Okay? You don't need to use any of that, really. Okay? That was all to help you remember this is what we covered last year. In fact, we covered it. You tested on it. You did well. You said, oh, yeah, I get it. I switched the x and y values. I look for the y instead of the x. I do all that stuff. You were good at it. But you forget it, right? Except other things to do, like Western and humanities and all sorts of stuff, okay? So the question is, what about the derivatives of these inverse functions? It says, using the function above, determine the derivative f prime of 4 algebraically and using your calculator. We will not use the calculator. And check a graph to assess the reasonableness of your answer. We've kind of already looked at the graph, but the whole idea is I'd like to find f inverse prime of 4. Okay? So again, I just want you to think about where we're at. We say that y is equal to 3x minus 2, right? That's f of x. So suppose you encountered a problem on the AP exam or in my class, and it said, hey, find not the derivative of the function at 4, find the derivative of the inverse function at 4. Well, what's the derivative of this? 3. So the derivative of this function at 4 would simply just be 3. Everybody agree with that? Well, if they said, well, find the derivative of the inverse function at 4, what you would say is, well, first what I need to do is I need to actually find the derivative, or I need to find the inverse itself. What is the inverse? What do we determine it to be? Yeah, we got y is equal to 1/3 x plus 2/3. Okay. And, we find that derivative, and, you're going to find, so this is f inverse of x. Well, what's the derivative of that? It's the derivative is 1/3, right? So the derivative of the original function is 3. The derivative of the inverse function is 1/3. So you could manually actually find the inverse and then plug in the appropriate values, correct? Yeah, you sure could. You sure could. There's an easier way to do it. So flip it over. I'm going to show you the easier way to go about it. It doesn't matter what value we plug in for a line. The rate of change is always 3, or the rate of change is always 1/3, right? So for example, if I said that I would like you to find f prime of 8, and f of x is equal, or what? And f of x is equal to 5x minus 1. What's the derivative? 5. So does it matter whether you're finding f prime of 8 or f prime of 10 or f prime of 20, the derivative is always 5, isn't it? So we didn't have to worry about that value at all. But you will, because we're not always going to do lines, and I'm going to show you that right now. Okay, we're going to skip this example 2. We're going to go into the derivative of inverse functions. This is the definition. If f is 1 to 1, a function that's 1 to 1 passes the horizontal line test. It means that it has an inverse. So assuming that the function is 1 to 1 and has an inverse, and it's differentiable, meaning you could take the derivative, okay? And the inverse function g is equal to f inverse. And f inverse of g of a does not equal 0. You'll see why that pops up in a second. Then the inverse function is differentiable at a and g prime which is the derivative of the inverse at point A is equal to, here's how we determine it. We use this formula. 1 over f prime of f inverse of A. That one formula can get you an extra 1 or 2 points on the AP exam. Okay? So it says, given this following function, find f inverse prime of A. I don't like finding the inverse of that function. That looks like it would be a little bit difficult. Would you agree? So what I'm going to do is I'm going to use this formula, okay? It says find f inverse prime at A. So f inverse prime at 6. And what I can do for that is I set up a little bit of chart to work this out, okay? Make the chart just a little bit bigger. Notice how there's 3 operations that happen here. It starts with f inverse. After f inverse, it moves to f prime. And after f prime, it moves to 1 over. See that? So I'm going to start by finding f inverse of A right here. Then I'm going to find f prime. And then I'm going to do 1 over whatever I get. Okay with that? Okay. So this is the most complicated part to get through. Once you get through this, you're going to be absolutely fine. F inverse of 6. If I wanted to determine f of 6, what would I do? I would plug in 6 for x. If I want to find f inverse of 6, what do? I plug in 6 for y. Does everybody see that? The difference? So if I want to find f inverse of 6, I say 6 is equal to 3 over x minus 1. How do I solve that? Yep, so 6x minus 6 is equal to 3. So 6x is equal to 9. X is equal to 3 halves. So it turns out that f inverse of 6 produces 3 halves. Okay? Now I want to find f prime of 3 halves. So whatever you get in this box, you put in that box. Well, how do I do f prime? I have to find the derivative, right? How do you find this derivative? Quotient rule or chain rule would be fine. I'll do the chain rule here. 3 times x minus 1 to the negative 1 power. What's the inside? Outside. Derivative of 3u to the negative 1. And derivative of x minus 1 is 1. So you can see that the derivative is negative 3 over x minus 1 quantity squared. Is everybody okay with that? So f prime of 3 halves would be negative 3 over 3 over 2 minus 1 quantity squared. What's 3 halves minus 1? 1 half squared. 1/4, negative 3 divided by a fourth. Negative 12. So I take that negative 12 and I put it in here. So I have the derivative, and I plugged in 3 halves for x. 3 halves minus 1 is 1 half. 1 half squared is a fourth. Negative 3 divided by a fourth is negative 12. So my answer is negative 1/12. Seems a little bit long and cumbersome, doesn't it? Wait till you do a second example. It's going to go nice and quick. I want to be able to find f prime or f inverse prime of 3. Anytime you're asked to find the derivative of the inverse, set up the 3 boxes. What goes in the first one? F inverse of A, in this case, 3. What goes in the second box? What? No, I'm taking the derivative of the inverse. So I'm not writing this formula. What I'm writing is that I'm taking the derivative of the inverse function. So when it says take the derivative of the inverse function is f inverse, and I want to take the derivative of that at the point 3. And in order to do that, Grace, what I do is 1 over f prime of f inverse at 3. That is that. That better? Okay, f inverse of 3, what goes in the next box? F prime at whatever we come up here. And what do we do in the last one? 1 over. If you could just remember those 3 pieces, inverse, derivative, 1 over, then you're good to go. Does the 3 go in for the x or the y? The y. 3 equals root of x plus 1. What to do? Square it. And I get 9 equals x plus 1. X is? That was easy. Dump the 8 here. Now f prime of 8. So we need the derivative. How do you find the derivative of the root of x plus 1? Chain rule. Outside, you're the 1 half. Inside, derivative of the inside. Derivative of the outside. So it's 1 over 2 roots of 8 plus 1. What is the root of 8 plus 1? 3 times 2. We get 1 over 6. So what goes in here? 1 over 6 is 6. Nope, I always take the principal root when you do square root unless you're taking the square root of a variable like x squared. then list two solutions. So we'll write it out. As Grace asked, we'll say we want to find f inverse prime. We will find the derivative at 1, at negative 1, excuse me, which is 1 over f prime of f inverse at negative 1. It confuses me when I look at it. It's challenging for me to think through. So when I see I'm taking the derivative of an inverse function, I'm not taking the derivative of x cubed plus x minus 3. That's super easy. That's 3x squared plus 1. Plug in negative 1 and I get what? I get 4, right? I mean, that's easy. We're taking the derivative of the inverse. Well, that's kind of crazy. So in order to clarify my work for me, and this is just how I've worked through it, is I make 3 boxes. What goes in the first one? F inverse of, then, and then 1 over. Where do I start? Negative 1 equals x cubed plus x minus 3. Move the 1 over. 0 equals x cubed plus x minus 4. Does that factor? Oh, minus 2. Does that factor? It's cubic. Doesn't factor. So if it doesn't factor, what do? Quadratic would be of a second degree. It's not second degree, it's third. Give up? Yeah, synthetic division. Plug in a number. What do you want? 1. Let's see if 1 works. 1 cubed plus 1. 2 minus 2. Oh, hey, 1 worked. What do you know? Try to make it easy. So now I got to find f prime at 1. That's the whole point. You can't come up with multiple numbers because then it wouldn't pass the horizontal line test. If you come up with multiple numbers, there's a problem. Okay, so I've got to take the derivative, which is 3x squared plus 1, plug in the 1, and I get 4. So 1 over 4. That's the derivative. Okay, you see how I got 1? So I have the derivative. So I take the derivative. Derivative is 3x squared plus 1. Yes. Yep, we're always taking the derivative of the original function. Yep. Then we plug in 1. What's different about letter D? They don't give you a function as a rule. They give you a table. Fortunately, no, that would be really complicated. I like the way you think, but we're not going to go that difficult. Okay? What they want us to do in this problem, if they said, find f inverse prime at 6, we would say, well, hey, we know that rule. It's 1 over f prime of f inverse of 6. But that's super complicated to us. We want to make it easy. So what do we make? A table. We start with f inverse of 6, then f prime, then 1 over. F inverse of 6, does that mean I look at the x value or the y value? I look at a y value of 6. Which one of these, x, f of x, or f prime of x, is the y value? Yes. So 6 happens right here. So what is f inverse of 6? 3. I found the 6. I got to find 6 for the y value. Notice how on the last one, look at what you just did. You had a is -1, so you plugged in -1 for the y value. You found the x value. So 6 is the y value. Find the x value. The x value is 3. What do we do with that? We find the derivative at 3. What's the derivative at 3? -2. Now, I want to be clear, folks, as you look at this, if somebody was asked on the AP exam to state the derivative of the inverse at 6, what would maybe be the most likely choice on their part? I would say they would locate an x value of 6, take out f prime and say it's -3, right? Right. But you see why we go to this part. People might go to that part and say it's -2. Remember, it's 1 over. You do the last one on your own. I remember now from last year that I don't like this problem because it came out 4 and 4. I should have chosen something else because it doesn't build it into your brain that you look for the y value, not the x value. So should I should really change that, but I didn't. So I'll go to my notes right now and change it, but for next year. Question? It's okay. I think you guys get the idea. We find the y value, we bring it to the x value, we find the derivative of that x value, and we go 1 over. The answer is -1/3. Good.